Artificial intelligence is a bit like a human who is inside something else. It's not as smart as you, but it could be as smart as you in the future. I believe that we'll become robots at some point, too.
Artificial intelligence is changing our lives. But what can it really do? What will change? And what will remain science fiction? To answer these questions, we embarked on a journey to meet the scientists working on our future. Augsburg in southern Germany, home to the headquarters of KUKA, the world's leading manufacturer of industrial robots. Rainer Bischoff is head of research here and is considered to be one of the world's leading experts in this field. He and his team are working on a new generation of robots that learn independently, like children. The task, to recognize and sort building blocks.
This robotic system taught itself how to grab. In other words, there was no human programming the robot.
So he tried by himself?
He tried by himself, like a child. When he first started grabbing, he wasn't successful, except for in 1 to 2% of cases. But he observed himself. And by observing himself, the robot identified when an image successfully matched a particular grasping motion and when it didn't. He's applied what he learned, and now he can successfully grab these objects over 90% of the time. I didn't program him, and yet he's still learning the task by himself. Seeing that really motivates you.
But what if the robot sees a new object, such as pliers?
It's a nice example. Every child would just say, okay, grab and move those pliers over, no problem. But he's still failing.
He's failing because he doesn't know what kind of inertial force this object has to be able to grab it properly. But you can see how he's already trying out different methods, and in time, he may get the hang of it. I should add that he isn't trained after every attempt. He collects around 1,000 data, and then the neural net is retrained. So it's possible that if we let him try 1,000 times, now he would at least be able to grab them reliably.
Intelligent robots that learn by themselves. They can recognize parts, assemble them, and they can independently adapt to their environment with the help of AI. But we're only in the early development stages.
I have a favorite example, and that's chess. These days, there are computers or AI that can beat chess champions. But we don't have a robot that can reach into a bookcase, take out a chess set, open the box, take out the pieces one by one, set them up, and start playing. A 6-year-old can do that, but no existing robot can. So for the moment, whenever I need physical intelligence, we're still doomed to fail. And I think that will be the case for a few more years.
Yet machines are getting better and more intelligent. This video was produced using special effects. But this robot has learned how to play table tennis. He was built by researchers in Tübingen and shows how much is already possible in the real world.
How long will it take before robots are better than us in some areas?
Robots already are better than us in many areas, particularly those requiring non-variant repetition, a great deal of force, or a high degree of precision. The tasks current robots are not as good at as we are those involving sensors. There's no point denying that, and I think it will be another 10 or 20 years before we have robots that can hold a candle to humans in some areas.
We humans use all of our senses and can do more than smart robots. But the robots are beginning to learn. Artificial intelligence also plays an important role in a story that began in January 1982 in Mount Washington, New Hampshire. Hugh Hare was 17 years old at the time. Together with his friend Jeff Batzer, Hugh went up a mountain. But they were caught off guard by a change in the weather. A blizzard raged for 3 whole days. The missing boys were only found after 4 days. Both were alive, but they had severe frostbite. The doctors decided to amputate Hugh's legs just below the knee. 32 years later, Hugh Hare has AI legs, which he developed himself. He spoke on turning disability into opportunity at the TED conference in 2014.
Beginning to bridge the gap between disability and ability.
Dancer Adrian Haslett-Davis lost a leg in 2013 in the terrorist attack at the Boston Marathon. Thanks to Boston, home to the Massachusetts Institute of Technology. We met with Hugh Hare to talk about artificial intelligence and the human body. He's the pioneer in the field of intelligent prosthetics, a single person who is both developer and user. There are dozens of prototypes in his lab.
So this is, you have a motor, you have...
Yeah, here's a motor, and this is a synthetic subtalar joint for inversion, eversion. So we've iterated and spent millions of dollars to arrive at this optimal architecture.
Hugh began developing prostheses after his lower limbs had been amputated. His replacement legs became increasingly complex. Now they are AI limbs with countless sensors, motors, and computers.
I quickly realized that I had an opportunity, that from my knees down, there was a blank slate, and I could create anything in that space that I could conceive and imagine. And so as a young man, I started to imagine what that blank space may look like, what may fill that space.
Disability depends on perspective. Hugh Hare has developed a novel answer. With the special prostheses that he's developed himself, he can once again pursue his greatest passion, climbing.
So there is a computer in here?
There's 3, actually.
3?
And they're each
Okay.
the size of your thumbnail. So very small microprocessors. And there's a muscle tendon-like motor system. So the computer runs algorithms and receives sensory information. So the device is measuring its position, speed, accelerations, temperatures, and whatnot. All that information goes into the computer. The computer runs algorithms and then decides on the actions of the muscle tendon-like motor system. And this all happens very fast, so as I'm walking and going up and down hills and steps, it's constantly responding to my biomechanical needs.
It is so good that even nowadays you do mountain climbing, or you still go climbing.
Absolutely. And I run, and Yeah, you cannot with a straight face say that I'm disabled. I trail run, I play tennis, I mountain climb, I do whatever I want to do physically. Now, if you remove the technology from my body, I'm severely disabled, I'm crippled. But with the technology in this sophisticated human-machine interaction, I'm freed from the shackles of disability.
Are intelligent prostheses only the beginning? Will technology increasingly merge with the human body? Intelligent humanoids have already been depicted in feature films such as Ex Machina.
You shouldn't trust Nathan. You shouldn't trust anything he says.
We're closing the loop between the synthetic robotic limb and the human brain, the human nervous system. What that means is the person can think, send descending commands down through the nerves, and then we measure those commands, and they control synthetic motors on the bionic limb. And then we're also closing the loop, so sensors on the bionic limb input information into the nervous system, so the person can feel the bionic limb moving, its position, its sensations, as if it's part of their body.
This is almost philosophical, because you have the body and you have the machine, and you sort of start merging them together, huh?
Yeah, and we're gaining evidence that when a human being can feel a synthetic body part, when they can touch it and it feels like normal touch, when they move it and it feels like a normal joint movement, that the synthetic object becomes part of their body, their identity, their self. Well, what's cool about having a significant part of your body that's designable and synthetic is you can upgrade. So given that I'm an MIT professor, I'm upgraded every week. I get new software and hardware.
That's interesting.
So,
I grow older.
Right.
No
Exactly.
upgrade, and you can get new
Right.
limbs.
So the synthetic part of my body is improving in time. My biological body is degenerating, which is very peculiar.
For Hugh Hare, artificial intelligence is a blessing. By the time our interview was over, a snowstorm was raging in Boston. An interesting coincidence, as this was also how Hugh's transition began. Thanks to AI, body and machine are slowly merging. Artificial intelligence is also increasingly determining our communication. It's there, behind every search, hidden from view. In social networks, intelligent algorithms control what we see and thus influence what we read and what we don't. But there's a problem: fake news. Capturing and reselling our attention and our digital data has become big business. Information technology firms are among the most valuable companies in the world. Facebook, YouTube, and Twitter have changed the media worldwide. But exactly what role do their intelligent algorithms play in the spread of fake news? In 2018, a team of scientists from Boston analyzed the spread of fake news. The study was led by Professor Sinan Aral. It was the largest worldwide study that had ever been conducted on the spread of fake news on social networks.
While information is abundant, attention is scarce. So there's way more information than we can process. And so these platforms help us by curating the information and, as you said, prioritizing what comes first in our news feed, what comes second, what comes third. And they have a machine, an algorithm based on machine learning that is deciding what gets shown first, second, third, or in fact, what gets shown at all. Some things are not shown. It's not the case that every piece of information is shown to everyone.
But which criteria do Facebook and Twitter use to program their algorithms?
The incentives of the people writing those algorithms are based on the incentives of the platforms, the companies that they work for. Those companies are based on an economic model of engagement. The more people are engaged, the more opportunities you have to show ads, and so you have more inventory for advertisements. But the second important reason is that the more people are engaged, the more you learn about who they are and what they like, and the more sophisticated the targeting is in terms of advertising. So engagement is a key factor for the economic success of the social media industrial complex.
Daily internet usage is increasing worldwide. In 2018 in Germany, the average was over 3 hours a day. For younger people, it was just under 6 hours a day.
Things that are exciting, novel, surprising, things that are potentially shocking are more likely to be engaging, clicked on, read, viewed, shared, liked, and therefore there are elements of the models that determine the news feed that favor engagement.
The following case from Japan shows what fake news and social networks can lead to. Videos showing young women who allegedly became ill after a cervical cancer vaccine were posted online. At the same time, unverified scientific studies were circulated on social networks. Both videos and studies were picked up by television. This led to the vaccination rate against cervical cancer in Japan falling from 70% to less than 1%. How could it be that false information could turn an industrialized country like Japan against a globally recognized vaccination? Hamburg, where we meet Riko Muranaka. The doctor had tried to counteract the anti-vaccine hysteria and inform the public online. But then she was targeted.
I was harshly attacked in the Twitters or social media when I started writing about the safety of the vaccines. They even tried to threaten me by sending all those blackmailing messages to my family or me.
Rika continued undeterred. She analysed the vaccination opponents' facts, checked the scientific validity of their experiments, and published her results in a book.
After all, I was just stormed by the criticism, and one day I just decided to shut up Twitter for a while. But when I got the John Maddox Prize, actually John Maddox Prize became a Twitter trend of Japan.
But even that didn't change public opinion in Japan. Despite top scientists sharing Riko's view, she eventually lost the battle to fake news.
They accuse me because my writing is wrong and my writing is giving wrong impact to the society and I'm hiding the truth. But it's not, it's the contrary. I'm telling the truth and people feel I'm hiding the truth. It's really interesting, isn't it?
The WHO sees the anti-vaccine movement as a global health threat. In Japan, around 3,000 women will probably die every year from cervical cancer because they choose not to get vaccinated. Fake news can be fatal.
The false information is moving through human society in a digital sense like lightning, while the truth is essentially, at the speed of molasses, sort of dripping very slowly from person to person to person.
The spread of false information, shown here in orange, and correct information, seen here in blue. Sinan Aral has studied these patterns on Twitter more closely than anyone else.
False news traveled further, faster, deeper, and more broadly than the truth in every category of information that we studied, sometimes by an order of magnitude difference. And this was particularly true of false political news, which was the most viral category of any type of false news that we studied.
Fake news.
We are fighting the fake news.
As you say, fake news.
Let's ask a question, sir. Go ahead. Sir, can you state, Mr. President-elect, go ahead. Can you state
Fake news has changed the political climate worldwide.
Can you give us a question? No, I'm not going to give you I'm not going to give you a question.
Social networks and their intelligent algorithms are increasing division in society. They vie for our attention, feeding us exactly the information we like. What counts are click rates, quotas, and length of stay. and not whether content is true or trustworthy. This personalized communication is dividing our society. Social networks assign each user a profile, depending on what she or he clicks on, reads, or watches. Those belonging to the red group here are mainly supplied with information that matches the red profile. Thus, a filter bubble is gradually formed. Everyone lives within their own network. Our opinion is echoed by like-minded people. Contradictory information and opinions hardly enter our bubbles. Media should be a mirror of society. But the AI algorithms are distorting the opinions we form based off our media consumption. Yet the media is too important to be left to people who are just out to make money.
5, 4, 3.
How will artificial intelligence change conflicts? What about intelligent autonomous weapons? The military is already testing prototypes, like here in California. 2 fighter jets launch a swarm of intelligent drones. The autonomous flying objects then identify their own targets. Should machines be allowed to take life or death decisions? We traveled to meet one of the most respected ethicists on autonomous weapons in the US. He warns of uncontrollable development and is committed to a worldwide ban on autonomous weapons. We visited Yale professor Wendell Gelding in his house north of New York.
Sometimes people do not fully understand what lethal autonomous weapons systems are. They tend to think of drones that might have facial recognition software and would pick off a terrorist that it sees in the distance, or perhaps a few robotic soldiers on a battlefield. What is sometimes not fully appreciated is lethal autonomy is not a weapon system. It is feature sets which can be added to any weapon system, and that includes atomic weapons or other high-powered munitions. And the feature sets would be the ability to pick a target and destroy that target with little or no active human intervention.
Intelligent image recognition, automatic target recognition. These AI techniques are already available. The global armament race has begun.
That machines do not make life and death decisions about humans. Humans make life and death decisions about humans. And when we open the door to machines making those decisions, we undermine the basic principle of a responsible human agent. Lethal autonomous weapons and self-driving cars, they're just the tip of an iceberg with something much larger below the surface. And that larger thing below the surface is autonomy in general, is autonomous systems in general. Autonomous systems threaten to undermine the foundational principle that there's an agent. And that agent can either be a human, or it can be a corporation, or be something else. But that there is an agent who is responsible and potentially culpable and liable for its actions, or for any actions that are taken. I can't think of anything more stupid than humanity going down a route where we have diluted the principle of responsibility, where we dilute it in such a way that nobody can be held responsible anymore if something truly dire takes place.
In the past, we have been too slow to recognize we were going down a wrong path. We need a worldwide ban on autonomous, intelligent weapons. Artificial intelligence will revolutionize industry. In Germany, the term Industry 4.0 has become a buzzword. Cars, robotic tools, and entire production plants are being linked via sensors and equipped with AI. But how will German companies fare in worldwide competition? Dr. Michael Bolle is the head of the Bosch Research Center in Renningen, Baden-Württemberg. Artificial intelligence is one of the main focus points here.
When it comes to industrial AI, the AI that plays a role in products, then I think that the technology companies that have decades of experience in the physical world, in real-life objects, and the corresponding experience in development and production have a competitive advantage when adding in machine learning and artificial intelligence. They have an advantage over companies that come purely from the virtual world. So I'm confident. And this is also the reason why we're investing so much in this area, and why we're rolling out and applying this expertise across the group.
Germany has faith in its decades-long technical expertise together with AI. Future stem from. We meet Hong Yang. She's Chinese and has worked for a German company for several years. We asked her what is different in China.
Culturally speaking, we are different. You know, in the traditional thinking, we are more open to the latest technology and open for the world. Yeah, so probably you can see from how much we are using the smartphone. Okay. Right? Like just now, we buy the coffee with a smartphone. And we pay for the taxi bill with a smartphone. And sometimes my German colleagues, they are astonished to say that you don't even have to bring cash with you. And I said, yeah, that's normal life.
I always forget my wallet when I'm in Germany, because here in China, I pay for everything with my smartphone. If you go to the market and there's an 80-year-old woman selling produce, you might think, I guess I'll pay with cash, but you can't anymore. You'll be buying an apple, and she'll take out a QR code, scan it, and then you pay for it with your smartphone. It's unbelievable. There's nothing like that in Germany. It's crazy.
For example, if I have dinner with my friends, and all of us has to, hand out your phones, and we put phones on the table. And then, if somebody's picking up the phone by calls or by text message or by WeChat message, he has to pay for the bill. That's the punishment. So we can feel the advantage of the technology, but when you get used to it, you start to reflect. What kind of impact to my life? What is the good part, what is the bad part? And then in terms of bad part, I mean, by nature, everyone will start to think about how can I get rid of the bad part, but still trying to keep the good part.
Young China is catching up, and the whole nation is hungry for progress.
Was ist das Besondere an China?
The speed. Just think about where China was 40 years ago, and now things are going full throttle.
China has even surpassed the US when it comes to filing AI patents. One example is the mobile transportation service Didi. Active in 400 Chinese cities, the platform organizes some 30 million trips a day.
Each Didi vehicle is equipped with a data logger, which registers whether the car is stationary or moving or whether there's a traffic jam. The data is also used to improve information on traffic flow in big cities. We call this real-time traffic information, or RTTI. The Didi data go directly into the RTTI, which gives you a much more reliable view of whether roads are congested or not than in German cities. Connecting everything with everything else and generating added value from that. The Chinese are really, really good at that.
Da sind die Chinesen schon richtig, richtig gut.
China is a much younger nation. There's a lot of energy and enthusiasm about what's to come. There are a lot of investments. There are great education institutions here. For example, Tsinghua University in Beijing and Tongji University in Shanghai are really top level. There are really many capable people. The talent pool here is huge. So I think there's a good chance that China will be leading.
It's predicted that in 2030, 37% of all scientists will be Chinese. Only 1.4% will be from Germany. And while Germany is currently facing a lack of science teachers at schools, a young generation of innovators is growing up in China. They have top-level education, fresh ideas, and they're hungry for success. One example is the DJI company from Shenzhen. It was founded in 2006 by a young engineer. Today, it's the world's largest manufacturer of civilian drones. Chief Development Officer Martin Brandenburg shows us the latest model. The new drone uses intelligent image recognition and can independently pursue its target. Equipped with dozens of sensors and smart positioning, it can detect obstacles such as trees or bushes.
The tree saves my life. Noch ist es so.
The tree was the limit because the drone says no.
In this case, the drone said, I can't fly through it safely, so I'd better stop.
As I understand it, it's very common here in China to combine things: facial recognition, navigating, flying.
Yes, and in this case, only visuals were used. You don't have a Bluetooth transmitter or anything else on you. The pilot simply says, I want to follow Ranga on the display, confirms, and then the drone follows you.
Innovation made in China. Chinese television proudly reports such successes. China no longer copies. Modern-day China invents.
DJI is truly the first global brand with a completely new product range from China. Before, China was primarily known as the world's factory. That's changing now, and the perception is also changing. Our company alone employs almost 3,000 engineers, really smart people. They're all enthusiastic. They're motivated. They want to create something new. And that's the spirit that prevails in this country. That's going to persist. A hunger for innovation is what defines modern China.
And China's economy is booming. Cities such as Shenzhen, Chengdu, or Guangzhou have the same economic output as entire European countries. The country is investing in its young people. Take the example of RoboMaster. Here, a team is preparing for the upcoming season. Each team has to program and optimize a gaming robot. The final is a nationwide event. Troy Quinn supervises the competition and shows us the parkour.
This one is this year's the latest one.
Okay.
And also we have a...
It doesn't shoot right now.
It doesn't shoot, right, sure. As we can see, there is the pedal right here, and it's the reference system. It's for sensing the bullet. When you strike it, you can see flashes.
Yeah.
That means you hit the button and it decreases the health. If the one robot loses all the points, it will shut down.
This may look like a game, but it's actually a program to support young engineers. It was launched by DJI, and now several other companies are also involved. The next generation of engineers needs to be good at designing and programming. And that's exactly what they're learning here in a playful context.
The background is serious engineering or more game?
It's serious engineering because you need to build a new robot. You not only put them together, it's just the first step. And then you need to do some coding, do some artificial recognitions. There's it's quite a massive work, and it's not that simple for maybe for college students.
How many universities are?
There's 32 university in the bio tournaments. But for this year, we have 170. 170 for all over the world registered for the competitions.
And how are the Chinese?
About 140.
And how good are they?
We shall see. Okay, maybe we can get hands on the robots and experience how it works.
Okay, we have 2 robots, so we'll now try and have a look at it. Okay.
Troy needs just a few key combinations to control the robot.
We'll go forward, backward.
Forward? Wait.
W for forward.
I'm an old guy, you know?
Oops. So you can see me. Right.
And now you fire at me? No, I fire at you.
Oh, you can fire me. But we are teammates, right? We are hey, we don't fire a single teammate, right?
Okay.
Because we are both sides. Okay.
The final is a major event. 20,000 people are in the audience. Another 30 million watch the contest online. Engineers and programmers are China's new pop stars.
They really care about this game because the teams from their schools win the glory from the games. That means a lot for them.
The students invested thousands of hours into developing their robots. The winner of the 2018 competition was the team from Southern China University of Technology. All of China celebrated their success. There are also excellent initiatives in Germany. One example is the so-called Ideen Expo in Hanover. Around 300,000 students come here within a single week. It's the largest classroom in Europe. Young people are introduced to new tech, learn how to program and design new circuits. And they seem to love it. But in contrast to China, German media hardly take note. Germany talks too little about its successes. We too can keep up with the global AI race, if we want to, but we really have to step on the gas. Children are now growing up with smartphones, internet, and intelligent toys. But what does that do to children? We met scientist Stefania Druge to discuss. Following research in Boston, she's currently working in Berlin. The generation after the internet generation is the AI generation. They're growing up surrounded by AI, like Alexa, for example.
You know, this device was not designed for children, right? This device was designed for households, so families make purchases via this device. And I think it's very important to recognize when we talk about kids and when we talk about regulation for smart toys and regulation of devices that record data about our kids, to understand who made these devices and what was the ultimate goal of this device.
Just imagine you in some years, you might also have children. Would you sort of install Alexa in your home?
It depends what Alexa, the platform, would look like then, where I would live.
Right now?
Right now, no.
Alexa, how many seconds are there in a year?
A calendar year has 31,536,000 seconds, and a leap year has 31,622,400 seconds.
That's not what I wanted to know.
Unlike Alexa, the small robot Cosmo was developed for children.
Trust and intelligence are related, because if I think that a device is smart, I tend to trust it more. So the younger children weren't so sure how smart these devices were, and the older children, they thought they're smart because they have a lot of data. So basically, the children that were like 3.5, 4 to 6 were more skeptical initially of these devices, and as soon as kids would go to school, they were more like trustworthy just because they saw how much information these devices have.
Curiosity, creativity, imagination. Children are open-minded and enjoy trying things out. Some devices react as if they were artificial living beings.
After they learn how to program it and train it, both the young children and the old children became more skeptical and trusted the device less. So they understood it knows how to answer this type of questions, but it doesn't know how to answer this type of questions.
Do you trust machines? Are they smart? What can you do that they can't? Stefania calls for increased understanding of artificial intelligence.
The goal of my research is to bring this AI literacy both to kids and parents, because these are in the home and parents are there also part of the conversation, asking questions. And I think it's important for families to understand how AI works in order to make a good use of this technology.
Some things promote our own creativity. Other things seem to be superfluous. And there's another important difference between humans and machines.
A friend can sleep over at your house and tell you stories. She talks to you. If you play with a robot, it can only do certain things. Cosmo can only play with dice. Alexa can only answer questions or sing a song. And that ball can only roll. Julia can do all those things. You just have to get a lot of single things from one robot, or get other robots. First this one, then that other, then the next. And with a person, you don't have to get a new one. You always have them there and they can do everything.
Marie and Julia hit the nail on the head. The robot cannot replace a best friend, no matter how smart it is. A machine cannot substitute a human being. Here, our journey through the world of artificial intelligence draws to a close. There will be major changes, but it is not the machines, but we humans who cause them. We not only have the freedom, but also the responsibility to shape our own future.